Hello guys. I'm audible?
Yes, yes.
Okay. So guys, have you received your welcome kit with the lab access? Have you checked?
I just received it actually. Yeah.
Okay. What about you, Prakash? Have you received it?
Yes, sir.
Okay. Have you tried to log in?
Yes, sir.
Okay. What about you, Aditya? Have you received?
Yes, sir, I received.
Okay. But did you guys try to log in or not?
Mm,
Okay. So see, your welcome kit email, which we have sent you, it will have three important matter. The first matter is how you access the web portal. So web portal is where your live class and recordings are placed. Then you will have the access to your lab access, where you will practice the CCNA material. And if you have any issues meanwhile practicing or you need any assistance on home lab, so this is our DL, which will help you to talk to our backend and they will guide you. So that is the three items in your welcome kit mail. So let me show you the first item, which is the web portal. So you will see that there are meetings scheduled and you can join directly from here, or I'll give you the Zoom meeting initial time so that you don't miss it. Once the class is done, the recording will automatically be displayed here. So you can see there is one video which we had as an introduction. And today we are the video that the class that we are gonna cover, it's getting recorded and it will automatically reflect here. So this is your web portal. And regarding the lab access, you have your own credentials. Using that credential, you can log in. Once you log in, there is a icon called GNS. You double click that icon, and this is how it would appear for you. Okay, this is a very fresh lab. We have not yet configured. As I told you, I'll do this topology just in front of you. So you understand how the users are connected to switch, how switch is connected to a firewall, or a firewall is connected to router. So we'll check that in a live class. And in the last class, we were talking about some routers, right? We were discussing about routers. So what is a router? What does router do?
the
Connects.
router is interconnect different networks.
Yes, it will interconnect the different networks.
And sir, router will decide the shortest path. Like, what's
Yes,
the router do?
yes. So do you remember the three paths we were discussing? What are those three paths which we were discussing yesterday?
About Japan, America, and US.
Yes, correct. Yes.
Australia.
Yeah. So that was just that was just a imaginary thing. It's not that it will always take that way. Just in a lab, we put some cost metrics. So we said that Japan is better than Australia or US. Okay, so before we get into these devices, I want to show you the 3D picture of these boxes. How does it look like? So you understand it in a better way. So let's take one box, let's say 8300 series device. There's also something called as Cisco 3D. Okay, let me see if that app is still available or Cisco has removed it. Okay, so you guys can also install this. I'm gonna give it right away on your Zoom meeting. I'll also tell you what this does or what is the significance of this. Let me first download it myself. So these are the CX catalog. You can check the device virtually sitting on the laptop. You don't need to have the device, or you don't need yourself to be present in front of a device. You just install this small application.
So did we lose you or?
Yeah, sorry, actually I lost for a second. 1 second, let me see what's the condition here. Okay, see, it has been downloaded and it's been installed. Let me take you to the product catalog. I click on product catalog. There are multiple flavors, multiple products by Cisco. So since we are talking about router, so let me click router. Now there are different families. We call them as a families, okay? ASR or ISR, Catalyst. These are all different vendors or different families by Cisco product itself. So let me take one simple box which says 900 series. So you see this 900 series, it's in a basic version. It's a very basic standalone version. So this is how the box should look like. Might be the Indian price of this box could be a 40,000 to 80,000. Okay. The problem with these boxes are you can use these boxes in such environment where you have the user size of 50 to 100 users. If you have 500 users, might be the throughput will create a problem for you. Throughput in the sense, there will be not enough bandwidth for the data to transfer. The bandwidth or the utilization will keep increasing. Let's say you purchase a laptop of 8 GB, but you install a game which needs 64 GB. You think your laptop can accumulate that. So that's why you go with a higher gaming laptop by paying 2 lakh, 3 lakh, 4 lakh, right? So similar way, this router is a model which a small scale customer most of the time go with. So for them, the usage is 10, 20, 30 users, and they are happy to go with it. So if you see this box carefully, there are a lot of IO ports, input output ports. So there is a aux port, there are RJ45 port, there is a power cord port, there is a optic fiber. Again, optic fiber might be present or may not be present, depending upon how much money you are paying for the box. If you're buying a very basic box, optic fibers may not be there. You might have that RJ45 cables. Have you seen RJ45 cables? I think you might, because these days every home internet we use them, right? Let me just show you if you have not used it. Have you seen RJ11 phone, RJ11 cables? These cables are your telephone cables. If you remember, the handset, the telephone handsets, they make use of this sort of very small ports. Okay, very small port. Whereas in the computer networking, we make use of RJ45 cables, which are a bit broader, and they have 8 color codings. We'll talk about all this color coding. I'll tell you what those colors are significance and what's the significance. So you see, this is how the color coding of that adapter looks like. So there are 8 different small tiny wires within a RJ45. So this RJ45 is plugged here on this ports, which you see here. Okay. And depending upon number of port, the price of a box is decided. So if a Cisco is charging you 40,000, might be he's giving you very less number of port, only 4 port. But 4 port is not sufficient. You want 16 port. So you have to pay accordingly, like 1 lakh for such number of ports. So depending upon port, the price will increase. And as I told you, this box is very, very simple box. It don't have hot swappable units. That means if the power is gone, you need to do the RMA of the entire box. But if you have products like multi-chassis, or if you have a very high-end product, those are hot swappable. That means you can take the power unit, the faulty unit. There will already another power back unit present there, and you can just RMA the small unit itself, and you can get back that unit and replace it back. Let me show you a advanced router. Say for example this. So these are advanced devices. This will cost 10 lakhs to 15 lakhs, one single unit. So you cannot recommend this to a small segment. You have to recommend this to a customer or company who has a data center, who is making millions of dollars. So he can afford this sort of devices. So here, these are hot swappable. That means if I have to, let's say if one of the unit is faulty, so what I can do is I can remove them off. Let me show you how do I remove it. So click this, and let's say I remove a line card. See, let's say the problem was with this. So why do you have to send or do the RMA of the entire box? You can just take this, send it back. They will give you a newer line card. You plug it back, right? Okay, so we'll talk about this in much detail. But for now, let's start doing our lab. So let me show you what are we gonna do now. Let's reconnect. So on the left hand side, you will see all your routers. So what I need to do is I need to get it here. I have to drag it. Okay, this way I can just drag it. And also if you need assistance while drawing the lab topology, you can enable all this grids and show grid. So what happens is that alignment sticks with the lab, so that you don't have to see. I can just drag it so that it sits properly in the box. So I just connect this way. Let me see my topology. Okay, so from this diagram, where is the router? Where is my router?
It's facing north.
Yeah, it is facing the north. Where are the switches placed usually? Towards the south direction, very extreme to the user connected. So for now, let's connect a simple 3 routers like we have in this lab topology. We need one more router. I'll keep it somewhere here at very center. Let's give some space. Okay, now it's fine. Now, when you have 3 devices, those labels are not very, they're not very looking impressive. So what labels did we give? We gave router 1, router 2, router 3. So I just double click on them. I'll say router 1. I'll give this as a router 2.
Sir, I guess your voice is breaking. Or
Is
else,
it for everyone?
For me, it is fine.
My native. Okay. Okay.
Okay, so see, I have labeled them as router 1, router 2, router 3 for my identification. Now I have to connect the cables, and I told you that RJ45 is the cable which we connect between the routers. Now this is a virtual environment. So how do I cable them? There is one option here. So I can just connect this from this switch port to the switch port of the router 1, and then so on. I can also connect it this way. Okay, and let me see if there is a connection between R2 and R3. Yes, there is a connection between R2 and R3. So I'll just do a connection from this to this. Okay, so we have three devices which are connected to each other. Now we have to configure them because these are only the hardwares. These are only the devices which are brand new devices. You just cable them from one end to another end, but they still doesn't know how to talk between these two people. So let's say this guy, let me mark it. So this guy, he is not aware of this router, neither of this router. Just keeping the cables doesn't mean that they start talking. Okay, you should also configure the software which is present inside it. You have to give the necessary IP addressing, necessary protocol. Then it will start recognizing that this is the person who is connected to me. It's like, for example, you are residing in one colony. This is your house. Your neighbor house is here. The neighbor house is here. If you don't come out of your house, would you know your neighbors? You will never know them. But if you come out of your home, even then it's not required that you know them if you don't start talking to them. So when you say hi, might be the other person will also reply back as hello. That is how you start communication, right? So same thing happens in this router. You might think now they are turned off, you just cabled it, they will not talk to each other. You bring them up, even then they don't talk to each other. You have to make some configuration on all three of them. Then the router 1 will start sending some hello message to router 2. Router 2 will send the hello message to router 1. So this is how the communication happens between all the three of them. So let's start their communication. So let's make a way that they can start talking to each other. So first, we will power on the device. You see the red LED, that means they are powered off as of now. So I just select all the three, right click, start them. See, now they turn to the green symbol. That means they are turned on now. They are getting boot up process. Like your mobile scenario, you turn off the mobile, they're off. But when you switch on, what happens? The operating system of that Android needs some time to get settled down, and then you have your beautiful wallpaper, etc., etc. So same thing, it will take some time. The first initial boot up will take some time, like 10 to 20 seconds. So you can see the software is getting loaded up, and once this is done, we are good to start with our configurations. So this is the console. This is called as console here. So this is router 1 console. This is router 2 console. And this is router 3. So all three routers are with me. So once they have been loaded, how do I verify that now I can start or I can begin with the configuration? I have to press enter. If you just press multiple enters, you can see the things are just getting up. See, they're just getting scrolled up. So now this has been completely booted up. Now we are good to start with the configuration. Same process on the second device. It has finished its booting process. Just press multiple enters. You're done. With the third router, similar behavior. Press multiple enters. You're just good with it. Now you see that though you kept router 1, router 2, router 3, but internally they are still showing you as routers. See, like this. It is same as you're keeping a label on your shirt saying that this is your name. You can keep any name, XYZ. Someone will look at your label and say, or might think that you are so and so person. But in actual, your name could be something else, right? You might be any ABC named person. So we have to now label these devices so that we know what's their actual name. So to do that, I just cannot name it over here because these are read-only patterns. These are only read-only. A router cannot be modified or do a configuration just over on the user privilege. This is called user privilege. To do any changes, I get into the configuration terminal. Okay. Then I say host name, and then I can decide the name. Let's say the name of this is router 1 and press enter. See, when you did that, the name also is changed. So similar way, I'll also change the name of the second device. I'll do a configure terminal. Then I do a host name. I say router 02. See, I change the name of it. I go to the third device. I do a configuration terminal. I say the name for this device is router 03. Okay, so it's a simple configuration. Let me show you on a notepad as well. You need this to remember because during your interview, definitely the interviewer is gonna ask, how do you change the name of a brand new router? So you should tell, you go to configure mode. Once you get into the configuration mode, then you type the command host name, and you can give any fancy name. You can give it as India router 01. Okay, or you can give it as primary New York router 1. So the name depends upon your company and the standard. Every company will have their L3, L4, L2 engineers, network engineers, who have decided what the standard of a new brand, a new device to be. So depending upon that, you will keep it. So for now, let me just mention that name to be decided or something, because as I told you, this can be anything, router 1, R01, India, or whatever. Once you do this, the best way to save them is put a write mem. Okay. Or you do one thing, first come out of that and do a write mem. So what happens here is, next time when you boot up the routers, whatever you previously configured should not get erased up, right? You want them to be saved so that you can keep on practicing your CCNA labs. Day 1, you might have configured something which you need for day 2. So you go to day 2, you will do some more lab and you will save it. Then you go to day 3, you will do some more changes and you will save it. So you have to save it. So to save that, we have this command called write memory. I'll show you what happens now. Let me give you one example. See, this router, I have configured the username, but I have not saved it. For some reason, there was a power outage and my device just got reloaded. Now what happens is, once it reloads back, I will see that all my configuration that I did previously is erased up, which is not good in production plus in your lab environment. because you don't want to reconfigure them. There can be outage due to this gap if you don't save it. So the best option is you save it, and even if something happens, let me show that in the second device. You save it, and then some power outage happens. Let's say I have some power outage. You will see the difference. This device will come back with pre-configured, that is as a router. All our changes are gone because we had not saved it. Whereas the second device will come back with all the configuration that we had put across on the device. So which is good. When you reboot your mobile, if you see all your files are gone, that is good. Or when you reboot your device or you reboot your mobile, you get all the things that you saved in your notepad, gallery, whatever you have it. If you have, that is impressive, right? So this is where you have to save it manually. Some tools, some places, they happens automatically. You might know that these days most of applications have a auto save concept. Like if you're using online Google Excel, Google Word document, they all have a auto save concept. You write something, power, there is a power outage, you don't need to worry, they auto saved it. But not on this scenario like routers. Okay, let me show here what has happened. See, on the second device, your configuration is present even if you restart it. But on your first device, configuration is lost. So you have to redo all your jobs, which is not a good idea. So we will just save it. We will save it on the third device also. Right now. Okay. So that is what we did now. So what is this? This is to configure host name. To configure host name on router, I'm going to give you this notepad, so you keep this always with you during your interview process. Just go ahead and refer it so that you don't need to rewatch 1 hour of video. You get all of them in a easy glance. Okay, so this is to configure host name and save them. What else we need to talk between these two things? I need to know where router 1 is placed, and router 1 needs to know where router 2 is placed. So let's give them some IP address on the interface. So to get the interface reflected, there is an option here. Okay, not this, the adjacent one. See. So router 1, if you see from router 1, this is called a switch port. Switch port is nothing but, let me show you simple image of Cisco router. Is basically where you have connected the cable. See, you see a lot of switch port here, right? So this can be gig Ethernet 0/0, 0/1, 0/2, 0/3. But how are you connecting a cable from this to this? Let's say you're connecting one cable from this switch port to this switch port. So that is what I'm going to use it now. So it is connected from gig 0/0 to, let's say, gig 0/2 or something. It can be any way. You can connect it any way. So that is what I'm trying to show you now. So I'll go back to my lab. I can see they are connected from gig 0/0 to 0/0 of this router. Same router on gig 0/2 is connected to the third router, and router 1 is connected to router 3 on 0/1. So we now know how are they connected, how is the cable, this cable, connected between one device to another device. And we also have the console. Now what I'm going to do, I'm going to assign some IP address. Have you attended any CCNA previously?
Sorry.
Or any? So you're listening to the old videos from networking background. I see you are listening to last class video. Okay, so let me open up all this console. Okay, so 1, 2, 3. I'll go to 1. We once again, okay, so tell me, Prakash, if I have to do any configuration, what is the command I have to use?
Configure.
Configure terminal.
Configure
Yeah.
terminal.
Okay, can I do any changes on this?
No, sir.
Yes. So to do any configuration, I'll get into configuration terminal. I can see the switch port by making use of do show IP int brief. It will show me all this interface 0/0, 0/1, 2, 3. But right now I'm interested in 0/0, okay, which is connected to router 2. So to get into that, I will say interface gigabit Ethernet 0/0, enter. IP address, let's go with a simple IP address 192.168.1.1, 255.255.255.0. It is a class C series. We have not discussed about IP segmenting now. IP address we have not discussed, which basically has something called class C IP in the range of 192.168, subnet of 24. So we'll talk about all these things. Okay. So for now, let's say I took one IP from this range. I press enter. I will say no shutdown because these interfaces are shut down, so that when you connect it from one device to other device, if this interface were configured with some other person or there was something else configured, there can be some issues in the network. The network can go into loop or can have some attacks. So usually they are admin shutdown. So the recommendation is, when you, let's say you have a uh, router which was used in a different data center. So you as a network engineer will first see, was there any old configuration? You will remove it and then you will bring it up by saying no shutdown. So I'm doing the same thing. I did no shutdown now. To see the configuration, most of people first come back to the user privilege by giving an end button, do the show IP int brief or whatever. You don't need to do that. In Cisco, you can just prefix something called do. You can say do show run interface gig 0/0. So GI is a short form for gigabit Ethernet, and press enter. So do you see the IP and no shutdown? So this is what is happened. If you check a running configuration, this is nothing but a running configuration of this interface. If you check for something else, it will not have any IP address. See, it is saying no IP and it is showing as shutdown. So you have configured that 0/0. So what did I do? Let me put it here. To configure interface gig 0/0 on router, we did configure terminal. We went to that interface. That interface can be anything. It can be 0/0. It can be 0/1 to whatever. So I'm just gonna put them as this so that you recall this way. After that, I did a no shutdown. I did IP address 192.168.1.1.255.255.255.0, and I just came out of that mode, or I can do a end and I can just do a write map. Okay, so I'll just do that. I'll do end and I'll do write map. So this is done. So what was this? This was a router 3, right? Okay. And on router 3, we configured the IP 1.1. Okay, I think we have missed one part. This configuration is supposed to be on router 1, not on router 3. So there was a mistake in using the right console. So let me do the configuration here. So interface gig 0/0 IP address 192.168.1.1.255.255.255.0, no shutdown and write mem. Okay, because that 0/0 is on this router. Here we don't have any 0/0. So let's not do on router 3. Now let me fix the router 2. I'll go to router 2. I'll say interface gig 0/0. I'll assign a IP address 192.168.1.2.255.255.255.0, no shutdown and write memory. Now both device have the respective things with them which can make them talk. But how do we know whether they are talking to each other? You can just initiate some ping packet. You can say 192.168.1.2. See, do you see this representation? The dot means there was a drop. They didn't talk for the first time. And then you saw exclamation mark. That means they are talking to each other. R1 knows where is R2, R2 knows where is R1. So you can also put multiple ping packets. You can send 20 packets and you can initiate the ping. Now you see all of them are exclamation marks. That means now they know each other. So what would have happened for the very first time? This is called as ARP broadcast. We will talk about ARP broadcast. So very first time, R1 doesn't know where is R2, neither R2 knows where is R1. So what R1 does it? R1 will send a packet with one TTL value inside it. Okay, it will send one packet which will have only one TTL value. This TTL value will get exited from all its interface. It will go to R3, it will go to R1, it will go to R4, wherever it is, it will just spread across. But then what happens is all the others will die because they are some different routers, not 1.2. But this 1.2 device will check that. It will see that the IP is something which is configured inside of me. It will start preparing its response packet and it will push back. So first packet always will be dropped because they doesn't know where exactly R1 and R2 is placed. So they are sending some hello packet. Might be on the first day, your neighbor don't want to greet you. But the second day when you resend him a greeting message, he has to respond back. He will respond back to you saying that hi, hello, or whatever it is. So that is what you see the exclamation mark now. So next time, and how do you know whether R1 knows R2? There is a tables. I see show IPR. See, I know where is 1.2 now. I am 1.1 and I know where is router 2, 1.2. And 1.2 is nothing but the MAC address of this interface. So if you go to R02 and if you do show interface gig 0/0, you will see some MAC address. See, you will see some MAC address. Hardware is so and so, and this is a physical address 0CD3. Do you see the same thing over here? Right? You see the same thing, right? 2B46 0CD3 2B46. You see that same thing here 0CD3 2B46. So now they know each other. R1 knows how R2 is connected, and the R2's MAC address will be stored in the R1's ARP table, address resolution protocol. So what command did I trigger to check this? I'll keep in the step 3. To check ARP table, I did show IPR. So in this table, I get to know whether R1 knows R2 or not. If I redo them, see, now they are neighbors. They know how they are connected. And also if you go back to R02 and do the similar command, show R, you know where R1 is connected. They are connected via, see, gig port 0/0. This is the MAC address of R01. And for last 4 minutes, they are neighbors. R1 no R2 for last 4 minutes. Any doubt so far? Okay, now this is a simple company network. Let me show you office network diagram. So let's say this is one office. This is users, sales team, marketing team, and so on. So they are getting the internet from their north faced direction routers or internet routers, which first will go through the internet or which will go through the network firewalls. Network firewall is connected to a switch. Switch is connected to all your end devices like your user machines. There can be what is this? Yeah, there is a printer here. There is a server. There can be a PC and lot of things. Okay, so switch will connect with multiple users. Routers will connect with multiple networks. So here the router is kept here. Router is next connecting with the router of your service provider. If you have a connection from Airtel or some other vendor, you will connect from one network to other network. Even in this case, in our case, let me give you the diagram. See, here we are connected with 3 routers, and this is a single office. So why do we need 3 routers? The job for the 3 routers is if one goes down, we have the second one acting as a standby. This is called a high availability concept in networking. You never give single device in enterprises because that device can go down anytime. Power issue, utilization, DOS attack, or ISP issues, internet service provider issue, right? So what is the best practice says? You connect this router. You connect this router with Airtel, and you connect the second router with Geo. So you have this connection between one of the service provider and you have another connection with another ISP or internet, so that if one goes down, you still have your reachability from another internet. So your users are not impacted because you are paying, your company is paying to 5,000 of users on a daily basis, right? Let's give an example, 5,000 employees per day. But due to the network outage, your users are just visiting to office, doing nothing, having cup of tea, going back. It's a production loss for the company, right? Might be there are so many customers who are impacted. Might be there were so many new contracts that they could have signed on this particular day. So they are losing a lot of millions. So what they do is they prefer going with 2 connections. Some people also take a third connection. I'll tell you why they do this. All your primary links will be on a high bandwidth. Might be this, you are taking 1 gigabit per second speed internet with AT&T. Here you're taking a bit lower, let's say 512 Mbps, where you are where you can redirect like Facebook traffic or YouTube traffic. Whereas on the 1 gigabit per second, you can have your VPNs or corporate network. And you can also keep it 2 Mbps, very small link for your backup purpose or some sort of duo factor. You might have know the duo factors authentications and all. So you can have a separate network for that. Also, it helps you in a failover. If one goes down, you have the second one coming up, right? So only the intentions are that users should not be impacted in the networking. Users should be always as good as they connect anytime you have internet uptime. So the internet uptimes are never considered as 100%. There can be some reason, some bad configuration. So always we call it as 99.9%. Okay, at least try to have this. But anything like 99 is also bad. This is bad. Okay, 99 is extremely bad. You are supposed to have a network connection 100%, but that's not technically doable. But at least you should have this. That means one rare outage in 1 year. I can say that way. One network outage might be ISP down, might be power outage. Only one per year. If you have 2 to 3 in a day, that means you are somewhere in 70% now, or even less. So the uptime is considered as 70 or 60, which is not at all good in networking. If you have, let's say, one outage per 6 months, might be you are over here in the 99%. If you have frequent outage, your networking, the networks are not proper, or you don't have a high availability, you don't have a better infrastructures, you have daily 10-20 times of outage, which is extremely bad. So in that case, you can go with the cloud options like AWS or Azure, though they are expensive, but at least you don't risk your outages. Because if you have a outage, that can happen for 4 hours, one full day. So the production will also impact, right? So that is something which you need to remember. Guys, so that we did, I will recap and we will wind up for the day. You have any question, you let me know before I recap.
Yeah, are there any similar tools for Juniper, Palo Alto, and other vendors like the tool which you loaded in the first part
The
of the course?
CX cattle. No, there was for Palo, but now it's been removed. And for
Okay.
other vendors, I have not seen such 3D catalogs.
Okay. And also the other question I have is, since you brought up these uplinks, are you also going to cover how to do capacity estimation and capacity forecasting?
Yeah, I'll take one class, but it's not part of CCNA. The
Yeah.
capacity planning.
I know. Yeah.
I'll just give you some
Or maybe
details
we
like
can,
how it.
yeah, I can talk offline with you. I mean, like, yeah.
Okay, sure. Okay, guys. So now I'll also give you one small assignment or homework, because daily practicing is must. You get the lab access. You know whom to reach. Our DL or our support DL is with you. Reach them, get the lab done on your home lab or remote lab. Put these 3 routers, cable them. I need them to ping each other. That's all. Give any IP of your choice. Give any subnet. I have not come up with subnet as of now. You start with 24 itself. Whatever I did in the class, I just want you to replicate on your home lab and take the ping output and put on our final WhatsApp group. I want to see whether you are able to ping R1 to R2, R2 to R3, and R1 to R3. That's all. I don't want any other concept to be added up as of now, just try to ping them. And all the config that I have discussed today in the class, I'll give you attached in the web portal.
Sir, I have a question.
Yeah.
So now I'm asking that how the ping works. Basically, from where to where? Can you show me the diagram you draw later on?
See, this is the topology, right?
Yes.
Yeah. Tell me now.
Sir, I want to ask about the how ping works.
Okay.
So because there is different kinds of ping like ARP, TCP.
No. See, you are confusing yourself. Pings are not TCP, they are UDP packets. Okay, that is why I don't want to bring lot of things until I have covered it up. When we do OSI layer, we'll talk about all these protocols. For now,
Okay.
you just get the things done so that they are pingable. How the ping works, what are eco packet, what is eco type 8, what is eco type 0, it has its own day when I'll talk about them. Okay, but in simple way, the ping packets consist of echo reply and echo response. So a code message of 8 is initiated, and on the other side, it will reply back with echo code type of 0. So it's a reply and request. So that is the backend of a ping packet. And ping is not TCP packet. They are UDP packets. Okay. So
Okay.
topics like ping, ARP broadcast, trace route. Okay. So these are something which we will discuss when we have OSI done. So you will understand it in much better. For now, you just try to bring up the ping between them. They should talk to each other. That's enough.
Okay. Sir.
Okay. So we go step by step. Too many things in 1 hour is difficult for other people who are not from CCNA or networking background.
Sounds great.
Okay.
All
Sir.
right. So any
Thank you.
question?
No, sir.
Okay.
Sir, what about Cisco packet tracer?
See, as I told might be yesterday also, packet tracer will be not good enough for advanced commands. You go with GNS or EVNG.
Okay.
Okay. Packet tracer, you will start losing some commands from spanning tree while you do the OSPF authentication and OSPF virtual links. This will be not sufficient. It's very entry level software. Better to go with GNS and EVNG because this will later on help you with CCNP, CCI, firewalls, Python automation. This will not even have a Python automation capabilities. That's the reason. All right, guys. So we'll connect in the next class, and we will start with some IP subnetting and some OSI day by day. So starting few classes are very important. Don't miss it out. Later on, once we start configuring the routing protocols and etc., it will be more and more fun, and you will understand the flow. So first, I'm starting with the routing section. Later on, we will have the switching and the rest of the thing, because routing is very important when you attend for interviews and even in your prediction.
Yeah, just want to make sure we don't have Friday, Saturday, and Sunday, right?
Yes, it will be Monday to Thursday only.
Okay, cool. Thank you.
Okay, have a nice day. See you
This
tomorrow.
video will be uploaded, huh?
See you
Yes,
tomorrow.
it is already getting recorded directly in the web portal. You will have it access in just another 30 to 40 minutes.
Okay, sir.
Thank you, sir. Thank you, sir.
Thank you. See you tomorrow. Bye-bye.